Good morning. My name's Tom Ball. I'm going to be giving one of the last talks of the conference. I appreciate all of you who were able to stick by till the end. When they gave me my time slot, it was like, okay, we'll just see if there's going to be anyone besides myself here. I'm glad to see there is. Okay, so who am I? I'm a senior software engineer at Google. And I was the person that came up with J2ObjC, which is what we'll be talking about this trip. I also currently am working on the Dart VM, doing optimization work for Dart. And in the past at Google, I've made contributions to the Eclipse Java development kit and C development kit, mostly related to fixing bugs and, in the case of CDT, implementing new refactorings for them. Prior to that, I was a distinguished engineer at Sun, or as the real engineers like to call them, extinguished engineers. I worked on Jackpot at Sun Labs. Jackpot it's a part of NetBeans now, and it's a refactoring engine that's used inside of NetBeans for all of its transformations. Anything that does a syntax or semantic transformation is using the Jackpot engine. And prior to that, I worked on the JDK team for quite a while. Worked on Swing, AWT, way back when I implemented the debugger API. If you go way back, the language used to be called Oak. So the reason I mentioned Swing, by the way, oops, you've already seen all that. The reason I mentioned Swing by the way, is because there are some echoes of the work I'm doing here and also why J2ObjC doesn't do certain things. But first, why are we doing this project? Or as one of the tweets from the first day when we announced it said, Google, why on earth? Someone else said, oh, the horror. It's amazing. It was actually really fun to watch the Reddit stream as it's going along and seeing all these people who had basically read about 3, maybe 5 words off the promotion announcement and then had these incredibly detailed opinions. So, developers, what can you do? So, what were we? I came from a team that was working on a iOS app inside Google. And the whole team was frustrated because we were being asked to concurrently develop a web app, Android app, and iOS app. And the reason that was it was a problem was because it was started out as a GUID application, and then with the Android teams and the iOS teams having to do furious catch-up because the GUID team was just constantly making new changes really fast, pushing them out, and then our program managers would come in and say, so what's with you guys? Why are you so slow? So, and by the way, the last talk where they mentioned GUID and whether or not Google's keeping it up, obviously we are. And everything he said was spot on. We're not moving from one language to another. I think just in general, because I'll probably get some questions about it at the end, why does Google have so many languages and development platforms and stuff? And there's a very simple answer. We have something like 15 to 20,000 software developers. And if you can get even half of those people to agree on any platform, you've done a major bit of work. So, getting back to our application, I can't go into details because it hasn't released yet, but it is a Java-based, it did have a Java-based, or does, client-server service layer. It does data presentation. And unfortunately, because it's written in Java, the client-side part, it could be shared by GUID and Android, but not iOS. And as you probably know, when you've got a bunch of Java developers working together, a lot of changes come really fast and furious. It's a very productive language. And especially on the client side, the protocol that was talking between the client and server was changing constantly. Still is. So we had a crazy idea to solve the iOS, how do we get out of the hole that we're constantly finding ourselves in trying to play catch-up. That was we'd write a translator. We'd translate Java into iOS, Objective-C. And I won't name any names, but a senior vice president said, okay, we'll fund one engineer. Now, that became my job, but it won't work. And the reason I mention that is because he's not your typical manager who basically, sort of gradually lost all touch with current trends in development. He used to be a computer science professor at Stanford, and he still said it won't work. And the reason it won't work is because the goal we're trying to do is impossible. Just flat out. One of you who's figured out a way that we cannot do translation from Java to iOS, you're welcome to stand up and share it with us, but we already know. It's impossible. And the reason for that is because the Java and Objective-C semantic models are different. All languages are different to a certain extent. In this case, there are a lot of differences, and they're significant. But the good news is that Java and Objective-C actually have borrowed a lot from each other over the years. One, perhaps the most obvious, is that Java interfaces and Objective-C protocols are very, very similar. I don't know what James Gosling was thinking when he came up with protocols, with interfaces, but I would imagine that the work at the time had probably included the work that had been done in Objective-C, because that was back in '85. JVM classes, I say that as opposed to Java sources, JVM classes are similar to Objective-C. They don't have any inner types or generic types. I mean, they have some generic type information stuffed in there if you happen to need it for compilation, but basically the class types themselves don't use generics. And also in Objective-C in 2.0, they added the try, catch, finally, and synchronize keywords, and as you can probably guess, they work very much like the Java versions. Now, for those of you who can think back to school, pre-calculus, you remember, taught us that limits make the impossible useful. You can't divide by 0, but as you get really close, you can do some really interesting stuff. And so what we went into this project thinking is that close counts. We're not computer science theorists. We're software engineers, and we wanted to come up with a tool that can get our engineering work done and be able to provide quality work within a reasonable time frame. It's engineering constraints. So let's talk about those limits. And it's important because this is part of what will invalidate the people that stand up and carefully explain to me why this won't work. First off, we're only going to support client-side development. Those of you who are interested in developing the next great Mac OS server, or or want to translate, say, NetBeans into Objective-C, you're welcome to try. But, as Groucho Marx said in the skit in Duck Soup, he was a doctor, and the guy came over and he says, doctor, it hurts when I do this. And Groucho Marx looked at him and said, don't do that. So the command line tools and server code might work, but we're going to stay far, far away from user interface APIs. Just sorry, I've got too many scars from working on Swing, and it's just not going to happen. What we are going to focus on instead is what code can be reasonably shared between platforms. So the goal is not to create a single source base that magically gets transmuted into several different platforms. It's to say, okay, what's the bulk of the work, the engineering work that we're doing? What can we use that is shareable, reasonably shareable, and can be ported easily between these platforms? And that's what J2ObjC focuses on. We're going to require the iOS Foundation framework. Yes, there's a version of the Foundation framework that's available in open source that'll run on any platform. It's nice. We're not interested in that. We're trying to develop iOS applications, and so we're going to work on the core Foundation framework in order to make sure those work. Next thing that's important is we're only going to focus on what's needed by iOS application developers. If you're not developing an iOS app and you've got a great new enhancement request, you're welcome to contribute it. But that doesn't mean you're going to find resources from our small team in order to be able to implement it because of our focus. On the other hand, if you have an iOS app that has a reasonable request that we're not meeting, we'll jump right in and help you with it. And that's part of the engineering focus, is that real application needs are what drive our priorities. You know, our priorities are to a large extent driven by our contributors, who are all members of other application teams that are using this tool. And so in that regard, 100% Java compatibility is not a goal. And I'm sorry if that's a little heretical, but I don't work for Sun anymore. I can say it. But remember, one of the things as engineers you want to do is always buy before you build, if possible. So we looked at a few other solutions. FlexiCore in the box was one. It's a popular choice. Now, this is going back about a year and a half. So there are new solutions that have come out. I'll make mention of a couple of those toward the end. But this is what was available in the landscape at the time. So FlexiCore is an iOS port of the Dalvik, or Android VM, and Android APIs. We rejected it for our project for two reasons. One was it has a non-standard look and feel. And at the time, although it's no longer true, and that's why I put a line through it, it had iOS license conflicts. There was some code that just wasn't going to be validated. At the time, Apple had a very tight license restriction on being able to run interpreted code. Another project that is still viable today is XML-VM. I think J2ObjC and XLM-VM are tied in terms of tongue-twisting project names. But we found when we ran it on our source code that there were many translation bugs at the time. And there are significant pieces of the JRE missing. I mean, we have missing pieces as well, but they were the pieces that we needed that were missing. And this is no longer true, but at the time, their website said Objective-C was not supported. It's just not available. Since then, the good news is that the team's been restaffed, and there are people that are making active contributions. And I understand that it's a much stronger solution than it was when we started. So don't rule it out. Then the last one was this little project we found by doing a Google search, and J2ObjC. But it only did syntax translation. And anyone who's worked on Java translation knows that syntax is the easy part of the problem. It's the semantics of Java that really determine what the semantics of your application are going to be. And you want to preserve those across any translation. And the other obvious problem was that the output wouldn't build. So what you had was a early first start in terms of if you want to hand rewrite your application in Objective-C. And the project's in early development, and as far as we can tell, it's been abandoned. The last commit was about 2 years ago. Okay, so let's switch over. I've been contrasting, those are the problems we had. So what is J2ObjC? Well, if you're telling your non-technical friends, you can just say it's a new source translator, or if they go a little cross-eyed at that, just tell them it's a compiler. It converts Java source code to Objective-C. It has, as I mentioned, it has a foundation framework focus. It's embedded inside each translated file. You're going to see an import statement that imports the foundation. Important goal for us is no editing is required. Have any of you, I'm probably the only one who's old enough to remember this, but did any of you work with C-Front, the original C++ compiler? Oh, we've got one gray hair in the group. I've got gray hair as well. It just hasn't come out on top yet. C-Front was a translator of Objective-C to C that then you ran the output through the C compiler. And the output was really kind of hard to read, but it was very useful for being able to debug this early language when it was still under development. And then when 2.0 came out, compilers started to do direct C++ to object files. And we could do that, but right now, what we are outputting are files that can go directly into the C compiler. We have an open source JRE subset, which is similar to GWIT's in terms of scope. It's getting a little bigger than GWIT's because handsets have access to more interesting facilities than are available in a web app. we translate, build and link with an iOS app. So this generates files that are part of an iOS app. In fact, in Xcode, you can write a J2ObjC build rule such that your Java files are source files to Xcode, just like any of the other Objective-C files are, and you just run build and it just builds it all. And as I said, you can run with an Xcode or you can run on the command line. And then you debug either using Xcode or GDB. Those of you in the know would realize that's the same thing. Let's take a simple example. And of course, we start with Hello World because that's what everyone does. Even though, as I said, we're not a command line tool or a server tool. So this is probably not the best example, but the shortest iOS app example would be many, many pages. So as you can see at the top here, there's the JRE emulation import. That'll turn around and call the import the foundation classes. And then you have an interface and an implementation file that are matched to the Java class file. If you have multiple classes in the Java file, you'll have multiple sets of implementation and interfaces in the other. These actually go into two separate files, by the way. I jammed them together. There's a .h file, which will have the interface, and a .m file, which will have the implementation. And then there's a main method, just the same as there would be in Java. One thing you might notice is that looks a lot like C code, and that's because it is. Objective-C is a superset of C, and in many cases you can just thunk down and use C wherever you might wish to, and the translator does that for many of the primitive operations that are used. So in this case, we create an auto-release pool. I'll go into that in a little bit, and manipulate the arguments, which in this case we don't have any to worry about. But then we turn around and we call nslog, which is an equivalent to a print line if you were on your iOS device. So how do we use this? Well, J2ObjC command is just a script that you pass in Java-C-like parameters, such as source path, class path, output directory, and then you give it a Java file. And then we have a second command, J2ObjCC, which is just like GCC or Clang. In fact, it's just a thin wrapper that turns around and adds a couple of parameters to make it easy so that you don't have to type in the various paths that are needed to be able to compile the file. So in this case, we have the first example just outputs an object file, and it specifies an include directory. And the second case, it just goes directly and outputs a binary file, executable. And I mentioned that in this case, we're building a test because that allows us to, one of the features we support is JUnit. Oops. Apparently you can only go with one finger. Okay, what isn't J2ObjC? And I have to stress this slide quite a bit because invariably people come up on the project and they say, I've got this Android app and I just want to translate it over to iOS. Do it for me and let me know when you're done. That's not what the tool is. It's not a cross-platform application tool. It can be used to create cross-platform apps, but its focus is a little more narrow. And the big reason is because we don't have any cross-platform UI support. The next thing, J-Object, oh, thank you. OpenOffice, just the source, the spell checker just bit. Okay, so J2ObjC is not a Java emulator. Objective-C code is generated. This may seem obvious, but in the FAQ, we're regularly getting continued questions from this. We compile it to object files. We link it into applications. And the last piece to take away from this is that it's really not used for one-time source translation. You can do it, but you're going to wind up with a seafront-like mess of code that's going to be difficult to read. You can read it. We actually do some formatting, and we have standard naming between Java classes and Objective-C classes. And if you specify the line number password, option, it'll go through and it'll actually embed line numbers in it, just like a regular C file will. But it's really not for the translation. The reason for that is because comments are removed, and we reformat your output. So, one thing we want to stress going into this is that app design is important. There are a number of people that are heard about the project on the web, and they come in, and unfortunately we find out they're not really engineers. And I can sort of be a little snobbish about this because of the audience I'm here. I would assume all of you are engineers. And so, but it's just important when you're working with other people or you're considering a design, is that you need to understand and be able to refactor out shared code and be able to have that in a nice clean space. If you've got a big GUID app or an Android app, it's not going to be easy to convert it over because your UI code and your non-UI code is probably mixed in a bit. So first thing you want to do is go through and determine your shared code. Examples of shared code might be your client-server protocols, as I had mentioned. Business logic. What is it about this app that makes it worth whatever you're charging for it? Data presentation. So the next step you want to do, if you hadn't already done it, maybe everyone in this room already had, is you want to separate the data and program logic from your user interface. Keep them well isolated. It's generally good advice, by the way, for anybody that wants to have a multi-platform app, regardless of the tools or platforms you use to do it. And you can use various techniques to use this. You can use a model view controller. You can use presenter controller. There are lots of different patterns. It's all good. Doesn't matter. The important thing is you want to separate your data and your program, your business logic from your user interface. And then you want to isolate this shared code. It's really important that you just basically say, okay, here's my shared code chunk. Ideally, it becomes a separate library. So, what does J2ObjC support? We support the full Java 6 syntax. Java 7's coming. We support inner and anonymous classes, and I'm going to just run ahead here because you guys can read as well as I can read it off to you. Basically, the whole Java 6 syntax. A couple of interesting things that we do new is that we use Objective-C properties for fields. And for any of you who have worked on GWT, GWT has a nice feature called JSNI, JavaScript Native Interface. We have don't have a name for it, native code embedding the same way. So you specify a comment on your native method, and then you can just embed the Objective-C code that you want embedded in there. We're also, in the next version, going to also support regular native declarations with a JNI interface. And we support Java collections. And what's very important is we support JUnit. And the reason that's important is because if you've written a solid piece of Java engineering, hopefully maybe a third to a half, or ideally even more, of that project are tests. And so what a lot of cross-platform work winds up doing, unfortunately, is throwing away the tests. And so you wind up with a target that you don't necessarily have the same confidence in that you did the original project. And so it was really a key requirement of us that we be able to port our tests over as well as our application code. Okay, as I mentioned, we have a Java runtime. It's based on Apache Harmony and on Android Source. The reason we can mix the two is because Android's based on Apache Harmony. For those of you who aren't familiar with it, Apache Harmony is a clean room implementation of the Java runtime environment. And one thing that we really like about it is it also includes a lot of tests. For J2ObjC, we have a subset similar to GWT, since there are similar application focuses. And you can read all that, lang, IO, a lot of the util stuff. And as I mentioned, we use the tests for verification. Really important because we have some confidence in the JRE that the fact that the project being new normally wouldn't justify. So one of the things you have to decide as you're going in is what kind of memory, how are you going to manage memory? Because in iOS applications, that's a very important aspect. The default we use is resource counting. That's the old traditional way that iOS apps were created. And the translator will add, retain, release, auto-release calls automatically. It'll generate a dealloc method for you. And in the main method, if you remember the hello world, you saw an auto-release pool that was created. Auto-release pool is a way to be able to add references and say, the next time you get a chance, release them if their reference count is 0. Don't do it now, just do it eventually. And we use that quite a bit. The next option that we're that we support is automatic resource counting, or ARC. This is new as in iOS 5. And basically, the shorthand for this is Clang, the new compiler that is replacing GCC in iOS. The compiler does all the work that you see above. So it'll automatically figure out where it needs to retain, release, and auto-release. It handles deallocation. It handles the pools. On the plus, one advantage of that is it's more likely to get it right, simply because it's inspecting the code at a lower level. Also, they add information at the compilation level such that the linker can do additional work in order to optimize away the unnecessary calls that are needed there. And the reason that's important is because one of the dirty secrets of Objective-C that you won't hear from many iOS developers are Java's faster. The memory management needed to run with Objective-C is very slow. I can get into the reasons why, but basically it just is. Always has been, always will be. Full runtime support for ARC requires iOS 5 as a minimum. You can run on earlier versions. This is what your customers will be running. But it's a little riskier because you don't get zeroed references after they're released. Then the third memory management option is garbage collection. I know that's the one you went to first, but unfortunately, it's not supported on iOS. And it's being deprecated for macOS. So we support it, we'll generate code for it, but we don't really use it, and we don't encourage you to use it as well. So this is FAQ, frequently asked question number 1 by all Java developers. What about memory leaks? So what J2ObjC says is Apple has put a lot of documentation out and a lot of thought into what are the best practices for being able to manage memory effectively. And what we've tried to do is embody those rules into the code that gets translated. So it really helps. I mean, if we're generating bad code, and someone brings it to our attention, we're going to take out Apple's rules and we're going to compare it to what's being generated, and we'll figure out from there whether or not we're doing what's right. The constructors, one of the things we do that's a little different from iOS apps is our constructors return auto-released instances. The reason for that is unlike in Objective-C, which has certain rules about which types of methods return auto-released instances and which don't, auto-released instances are the ones that can be released because the auto-release pool knows about them. We don't know at the translation level necessarily how the instances that are being created by constructors are going to be used. So we just assume they're all going to need to be released at some point. Now that sounds like it's going to be a big burden, but it isn't, because on iOS, every time the event loop iterates, the auto-release pool gets released. So all of your garbage generated during an event handling is going to get released at that point. So we found it hasn't been an issue. It is an issue in benchmarks, though. And for most classes, that's enough. We generate code, it works, we put it on the instruments tool, and sure enough, it's not leaking memory, everything's good. And we recommend using this tool quite a bit. It's a really nice tool for doing memory management. Now, you may come up with a design, and we found a couple, that where you need to manually annotate where your reference cycles are in order to help Clang, the compiler, be able to release them. So we have a weak annotation, which just indicates that a variable has a weak relationship. We have a weak outer, which is used for inner classes in order to indicate that the outer reference is weak. That's because it's often easy for an inner and outer class to get into a deadly embrace. And then we also have an auto-release pool indicator. And that just says this is a good place to put an extra auto-release pool. Auto-release pools can be nested. And so it's okay to put them in. There's just a little overhead involved. We use auto-release pools here for our benchmarks in order to, because if you're going to do a couple million iterations before you return and actually release your pool, the pool's going to get pretty big. And the last thing we're working on right now that we ought to have out, hoping in a month or two, is a reference cycle reporter. So you run your code through it, and it statically analyzes it and reports potential references. And we're using that now on our own tools and applications, and it's looking pretty good so far, and once it's tuned up, we'll release it out to the world. So how does this translator work? Some of you can, who don't care about compilers might catch some Z's, but I'm hopefully reaching out to some of you that might consider contributing to the project. So J2ObjC uses regular modern compiler patterns. Any of you who've taken a compiler course in school will probably recognize what we're doing here. It has a front end that creates a semantic model of the Java source. This semantic model has fully attributed types and symbols. So you have a reference in a program, we know where it's uniquely used, where it's referenced. It doesn't matter if the names are the same. We can differentiate between the various symbols as well as have full type information on any type or any expressions type. It outputs an AST, abstract syntax tree, and its bindings for each of its nodes. Then the backend transforms this AST into an Objective-C model. So core Java types are mapped to foundation classes. We try to avoid unnecessary overhead. There isn't a Java Lang object emulated class. It just goes right to NS object. Anonymous and inner classes are transformed into outer classes. And initialization normalized as structures generated. And finally, our generators. We have a generator for the header file, for the output, for the implementation file, and for statements. They output the AST as Objective-C source files. But wait, you say, it's really tough to model Java effectively. And it is. I've been spending way too many years doing it. So instead of doing it, again, trying to be good engineers, we want to reuse wherever possible. So we use the Eclipse's compiler, or actually its Java Development Toolkit, which is the front end to its compiler. It has a public front end. So the tough part, we let JDT use. It parses and generates the AST for us. We don't have anything to do with that. So the first requirement that J2ObjC requires is that the source files you give it are compilable by a Java compiler. That may seem obvious, but you should see the bug reports that suggest people don't think of that. So basically, if JDT can't handle it, we won't even bother trying. We'll just report the errors. And the Eclipse compiler, and it's very almost bug-for-bug compatible with Java-C. So it's very unlikely that you're going to find compilable code that JDT won't be able to handle. And the reason this is important, if you're going to make a bet on J2ObjC, is that it's important to know that we start with a good semantic model. This is probably the Achilles heel for most translation tools, is that they either skimp or they just haven't put in the years and years of effort to create a really good semantic model of the program to begin with, which makes it very difficult to rely on the translated output. So, if you have a bad model, it's GIGO, garbage in, garbage out. But we don't, because we rely on JDT. So what are these translations? I'll just go over them a little briefly, but it might be interesting if you're thinking about, there's something in Java I do here that just can't go over to Objective-C. The rewriter is our oldest translator. Oh, and the way we work basically is each one of these translators run independently on the AST. They just hand the AST off. Each one of these morphs the AST slightly, and then at the end we write it all out. So rewriter goes first, and it adds things like some of the missing method declarations from interfaces and protocols. Objective-C requires that a protocol list all of its, and a class list all of its methods, whereas in Java it doesn't. If it's defined in an interface, it just knows it's there. We rename any reserved names, any members, and Objective-C doesn't have static variables, class variables. And so it actually does have static variables, but they're C static variables. So we convert them into C static variables, as well as provide class-level accessors. The autoboxer. Just like Java-C does and JDT, we add the autoboxing conversions because Java class files don't do any autoboxing. It's all done by magic by Java-C. Then we do an iOS type conversion, which maps the core types. So I mentioned object goes to NSObject, string goes to NSString, throwable goes to NSException. You get the idea. Following that, we do a method conversion where we map methods to the equivalents. One of the nice features of Objective-C is you can add methods to a class that you don't own. It's called someone help me out. Any iOS developers here? Categories. There we go. And so we have categories that add methods like clone or many of the string methods to the various core classes. We also support command line mapping files. So if you have your own mappings that you want to map to specific iOS files, you can do so as well. And we have lots more translations. Static initializers all get moved into an initialize method, which is a reserved method that's used for class initialization. And then we move the instance initializers into constructors. We have anonymous class converters. So we take the closure that an anonymous class depends on, and we convert that into parameters and pull it out so that it's an inner class. And then we turn around and extract all the inner classes and replace the references to the outer class with, again, parameters. Again, to have some confidence, one of the ways we're able to verify that we've got it right is we use Java P in order to dump out what Java-C is doing in terms of passing on parameters. Because remember, Java class files don't support anonymous or inner classes either. So it's, okay, what do the experts do in order to support this? And then we do the same. And we generate destructors. And one optional phase you can use is that if you use ProGuard and you give it a set of root classes, it'll generate a usage report which says these are the methods and classes that you don't use. And if you pass that report as is into the translator, it'll automatically strip those classes out. Now, J2ObjC isn't your only option as far as being able to translate Java files into Objective-C. One we like is called Codename1. It's a little tiny company that's been out fairly recently. They have a platform for being able to develop cross-platform Java mobile app tools. So you can write an app once and be able to run it on Android, iOS, and a few other platforms. And the important thing that they have that we don't is they've got a cross-platform user interface. And it's a nice piece. It's open source. It's based on the lightweight user interface toolkit that originally came from Sun and now is managed by Oracle. In fact, the lead developer for Luit, or however it's pronounced, is one of the, I think he's the CTO of Codename1. They have a nice visual design tool, and they have plugins to support Eclipse and NetBeans. Another tool that is useful is Oracle ADF, Application Developer Framework, I think it is. If you have an application that's Java Server Faces compatible, they have a component suite that will enable you to use those components in a way using Ajax. So it's a hybrid model. They have a mobile platform for Android and iOS, and it uses HTML5 and the Java 5 models in order to be able to give you apps that are sort of close to native, but not fully. The hybrid model has its advantages and disadvantages. So it's one you want to weigh carefully. It's useful for often being able to get a product out quickly, but we found, at least at Google, is that there's been pushback, because some of our tools were hybrid, some of our apps were hybrid apps, and we got a lot of pushback that they weren't real apps. I'm not saying Oracle ADF doesn't create real apps, it's just evaluate it carefully and make sure it's what your customers need. So this is an open source project. It's not a project where we're pretending to be open source. It really is. It was designed to be an open source project from the beginning. We don't have a program manager. We don't have a product manager. It's one reason the name is as hard to say as it is. It's just a tool that was created by engineers for engineers. And we welcome people to contribute to this project if you're interested, because translators are really fun to work on. And I know this may not, you may not believe it, but I've had a couple skeptics who've come into the project. One guy was assigned to it against his will, if you can believe it, and now he loves it. I mean, he's just going nuts. I started working with manipulating ASTs back in the Jackpot days, and it is addictive. It's a lot of fun to be able to not only get your hands completely around a project and understand it, but then to be able to go in and just twist it and have it work. It's a lot of fun. And I'm not just weird. I mean, there are other people that have the same sort of attraction. One important thing about this project that I think is one of the reasons why it rings true from an open source perspective is that our contributors are tool users. They're not in it because they want to write a translator. They're in it because they're using it and it doesn't quite meet what they need it to, and so they're going in and fixing it. So they're adding features and fixing bugs that their projects need first. In fact, I was the only full-time person on the project. Now I'm one of those contributors who use the tool. But in each case with the Java, as Google's apps team started adopting this tool, they would assign a single person to sort of be the point person. And then that person initially said, okay, well, here are the bugs we need, and when are you guys going to fix them? And then after, it usually takes about 2-3 weeks, all of a sudden the patches start coming. And then they start getting into it, and all of a sudden we've got another person that really likes working on the tool. It's great. It's a fun little team. Right now it's all Googlers, but we have 2 people that have submitted major patches externally. You're welcome. We're happy. Thank you. We've incorporated that, and we give full credit. The code generator changes can be really easy, and the reason for that is because in a lot of cases you're converting string output from one format to another. So if you see a bug where the code just isn't right, a lot of times you can search through the generator files and you can find, oh, that's where it's written. It should be written this way. And it makes it very easy to be able to make a small change, apply it to your source code, and then immediately verify that the file is right. In fact, that's how most of our unit tests are written, is we take little code fragments and we just run it through and we compare the output. So you want to come in and you're not sure you can work on a translator? Well, start with a generator. If you understand the code that's going in and what you want it to be, you can make generator changes. Now, doing AST modifications is a little harder. It can be a little tricky to make sure that you don't break the type system, but it has much better bragging rights. If you're in there and you've written a translator, and I say this because we had an intern who wrote the dead code eliminator. And the first thing he did, as soon as it went public, was he sent a note out to his both of his professors and just basically said, here's what I wrote, here's the file, isn't it cool? And of course the answer back was, yes it is. So we're going to be hiring him when he gets his master's. So for more information about the project site's J2ObjC at googlecode.com. There you'll find downloads, you'll find a full wiki with all the documentation, full source code, and a list of all the issues that are currently open. And it's an open source project, so you just download the source, build it, have fun with it. It's good. The address for email address for being able to send questions or just get into the discussions is at J2ObjC discuss at Google Groups. And that's also available on the website. So if you remember nothing else, it's J2ObjC at googlecode.com. Well, and thank you very much for listening. Okay, we have about 10 minutes for questions, if anyone has any. So I'm not sure. I heard people were saying things into microphones that I couldn't hear, but I can't see the microphones to see if anyone has any questions. Going once? Going twice? I guess everyone wants to get home. Oh, okay, yes. Oh, let's see if I get the question right. You were asking about mono or? Ah, here we go. It's a hardware problem.
Yeah, that's better.
Yes.
Sorry. So with new things like default code in interfaces, default implementation in interfaces in Java, do you think that's going to be an issue with adapting your model? Or,
no. Well, it is and it isn't. Right now, JDT doesn't support those features, so until they do, we won't have access to them. When they do, it's not a big deal. Java 7 support, for example, we have a number of different features. First thing we're going to do is we're going to turn the flag on in JDT, which already supports Java 7, and then we go through and we make sure, okay, what are the impacts on our AST and how do we change it? So it really is just a case of waiting for JDT and then seeing what they have and outputting it. Default code itself, it shouldn't be a problem though, because right now, I mean, we add methods and such as needed. So in this case, it would be just stuffing it in. We also, if you, for example, have a getter or a setter that you've written that does some interesting stuff, we will take that code and we'll embed it into the generated property that gets created by Clang. So we're already going through and cutting and pasting in your code into the appropriate places. Does that answer your question?
Yes, thank you.
Okay. Anyone else? Ah, yes. Oh, sorry. Go ahead.
My question is, how does J2ObjC deals with method overloading?
Yes. Good question. How does J2ObjC deal with method overloading? That we're done by using Objective-C has the notion of parameters, positions. And so what we do is we take the type information of each one of these parameters and we make the names into those. So if you had, say, for example, take an object with an index. So you've got an object and an int. Then it would be method name with object, colon, the object, and then with int, colon, the second value. Now what if you have a second int? You just add another one. And because we have the type information and embedded in there, and because it's positional, we're able to do the overloading in any manner. If they have different types, then they'll have different names for those parameters. Does that answer your question? Great. That also makes it a little harder to read. But if you know the types of your application, you can figure it out pretty easily. Anyone else? Ah, yes,
yeah.
Way in the top.
First off, great talk, interesting stuff. I'm over here.
Oh, thank you.
When you look at the Objective-C stuff,
yes.
and they tell you that handling exceptions is very costly in performance.
Yes.
Do you guys have an alternative to just translating it to exceptions?
No.
No. Okay.
No, and that's important. And here's an important thing to realize. In some cases, I think the Java VM has done too good of a job in terms of hiding ways that Java developers can really screw up their own performance. And I say that going back to, and the JDK is guilty of this as well. But the classic case that you need to avoid, regardless of whether you're going to stay in Java or whether you're going to translate it, is don't use exceptions for flow control. Exceptions should be used for exceptional conditions. That's what they're for. And in those exceptional conditions, performance shouldn't have nearly the impact that it would in normally running code. So in that case, I would say just basically you need to write your code so that exceptions are exceptional. And if not, then use the instruments tools that are in Xcode in order to see where your hotspots are. So I'm sorry, it's probably not the answer you were hoping for, but there isn't any magic. We use exceptions the way they're used, and they're actually not that much more expensive in Objective-C than exceptions are in Java. It's just we're so used to them, they just seem to go away.
On another project, Google
Yes.
Play N, they are also using something like Mono to translate Java code to for iOS. Is it also something that came in mind and that you investigated on, or?
We did. The question is whether or not we investigated Mono and the tools Mono Touch that converts Mono code into Objective-C. The drawback there was we were starting with an existing Java base. It wasn't written in... I haven't tried the Java to iOS using Mono Touch, but a year and a half ago it was C# code that was, or any code that runs on top of Mono would be able to be converted to iOS. And since our code wasn't running on Mono, we couldn't consider Mono Touch. It was also at that time there was some controversy about whether or not the Mono runtime was legal from iOS's legal standpoint, from its licensing. That was cleared up. It is legal. It's definitely a solid solution to use, especially if you're starting from day one. In that case, having a code base that can also support Windows 8, it's definitely one that's worth considering. Yes, Mono Touch is a good option to consider, especially if you're starting with a new project, at least in my opinion.
Okay,
Anyone else?
thanks.
We've got 4 minutes. Going once. He's running. We do have someone. Yes.
What were the hardest idioms, concepts of paradigms to translate between Java and Objective-C?
What were the hardest Java concepts to translate? That would be inner classes. I say we spent maybe a third of our time really getting inner classes right. And the reason for that is because, at least in Google, we've got a lot of Java developers there. And we've got a lot of really smart Java developers there. And we've got people that can do really strange things with Java there. I ran into one case, for example, where people were using enums. Did you know, for example, with an enum, you can have an inner class for each one of the enum constants? And they were using that as a building block in order to create a DSL. So they had their own domain-specific language that was done by stringing together enum constants. And it's like, whoa. So when we saw the code for that, the first thing we wanted to do was go, just don't do that. But we worked it through. Anonymous classes were also hard, but not as hard because there are only so many ways you can abuse them. So the good news is, from a translation side, is getting a tool from a development tool from Google means that you've got a lot of really smart people that have already ripped it to shreds. And if it survived that process, it's probably going to work for your code pretty well. I think I saw another hand. Yes.
Hi. Is there any famous Google apps or maybe non-Google apps using this tool?
No, I'm
right
sorry.
now?
The reason for that is because we've been in the process of getting rid of our hybrid apps. And so there's also, I can't go into top secret details and all that, they'd have to kill me. But basically, there's going to be some significant refreshes in the apps that are currently out there, as well as new apps that are coming out. And it's on a per app basis. Right now, the apps that are mostly interested are the Google Applications apps. So, you can imagine what those are. The ones you'd see on Google Drive when you pull it down and you say create a new. That's about as close as I can go. But you get the idea. But I'd say within the next 6 months, you'll start seeing them roll out. Oh, and the project I was on got canceled, but then it got merged into the tool into the app we were trying to replace. So they'll be coming out as well, but they had to do a reset. So, okay, if there aren't any other questions, I think we have no minutes left to go. Have a wonderful trip. Thank you very much for staying to the end. I appreciate it.